Right, 3.6. Calculate the coordinates of P, which is equidistant from L, S, and N. L, S, and N. This is a bit challenging, but now a point that is equidistant. What could this mean? It means P could be the center of a circle. Okay, P could be the center of a circle. So let's draw a circle here. It's not going to be perfect, but just to have a picture. Right, this is the circle. Right, should be a perfect circle, but if P is the center of the circle, it must be on Sn. Do you agree? It must be on Sn. Why am I saying that? Because this angle is 90 degrees. Angle NLS is 90 degrees, meaning that NS is actually the diameter of a circle. But remember, an angle subtended by diameter is 90 degrees, or you say an angle in the semicircle is 90 degrees. So it means NS is diameter, right? And then we're saying that converse angle in semicircle. P should be on NS. And then they are equidistant. This distance, PL, PS, Pn, they're equal because they're radar, isn't it? Okay, that's what we got from this. Now we can find the coordinates of P, because actually P is the midpoint of NS. P is the midpoint of NS. So we're saying P is x at S plus x at N divided by 2, and then y at S plus y at N divided by 2. So the coordinates of P are 4 plus negative 2 over 2, and then 5 plus negative 3 over 2. And then what do we get? P is having coordinates of 1, 1.